All right, so now that we're done with the review problems for Module 12, let's go ahead and start with the practice problems. I'll read the first one. It says, a balloon is filled with hydrogen at a temperature of 20 degrees Celsius and a pressure of 755 millimeters mercury. If the balloon's original volume was 1.05 liters, what will its new volume be at a higher altitude where the pressure is only 625 millimeters mercury? Assume the temperature stays the same. So let's go ahead and we're just going to list off to the side the different amounts that they give us, okay? So first P1, V1 over T1, P2, V2 over T2, okay? Now, this one said assume the temperature stays the same, so we're not going to be dealing with that at all, okay? So whenever they say this is constant or this stays the same or anything like that, you can just erase it because we're not going to need that portion of the equation. So these are what we're going to list off to the side. P1, V1, P2, V2. Figure out what we're solving for, move our equation around, and see how we can solve it. So they said, the first one they said was a pressure of 755 millimeters mercury. That's your first pressure right there, okay? And they said the next pressure is going to be 625. It goes down, okay? So I'm just filling in those two things. And they said, what will its new volume be? So I'm going to put a question mark right there. That's what I'm solving for. And then they said the balloon's original volume was 1.05 liters. Okay? So be aware they did give you a temperature, but at the very end they did say assume the temperature stays the same. So as long as they say that, we can get rid of it. You don't even need that. So let's rearrange to get our V2 by itself. So we just use a little bit of algebra. So do P2, this cancels. So my new, I'm going to always rewrite it so that I can see it plainly. P1, V1 over P2. So now I'm just going to go ahead and plug my stuff in. P1, 755 millimeters mercury, times your volume, 1.05 liters, over your second pressure, 625 millimeters mercury. So go ahead and crunch this through. Your unit here for pressure is going to cancel. It's going to leave you with a liters, which is good. That's what we're trying to find. And if I do that and pay attention to significant figures, I'm going to end up with 1.27 liters. Okay? So that's the first one. We're going to be doing very similar things for these first several. We're just going to be listing off the things that we know and then solving. All right. So let's look at number 2. Number 2 says, a bacterial culture isolated from sewage produced at 46.1 milliliters of methane gas at 25 degrees Celsius and 780 torr. What would be the volume for the methane at STP, standard temperature and pressure? So this is one of those that you need to know what those are, okay? And we'll walk through that. So let's first list the first ones. Let's T1, we'll do T2, we'll just add them right here. So they said your volume for the first one is 46.1 milliliter, okay? And then they said at 250 degrees Celsius. Now remember, I didn't mention this with the first one because we didn't use temperature. Remember, whenever we're doing all these problems, we can't work in Celsius. And guess what? They're probably going to give you almost all of them in Celsius. We need to take that and convert it to Kelvin every single time, okay? Because remember, we can't have a zero. We can't have anything that meets a zero on the bottom of our division because it won't produce an answer. So in order to get rid of that, we use our Kelvin scale because it doesn't reach absolute zero. So off to the side, I'm always going to do my equations off to the side. So they said 25 degrees Celsius. So I'm just going to take 273.15. I'm just going to add it. So I'm going to do this every single time and come up with my new temperature. So my new temperature is 298 Kelvin. And the pressure is 780 torr. So this is what we started off with, and now this is what it's going to change to. They said, what will be the volume, this is what I'm searching for, of the methane at STP. Remember, standard temperature and pressure. Our pressure is going to be 1 atmosphere, and our temperature is going to be 273 Kelvin. Those are our STP, okay? So I'm going to be solving for this. So up here, I've got V1, oops, no, that's right, P1, T1, V2, P2, T2. I'm solving for this one. So I'm going to put this one up top, put this one on the bottom, and I'm going to be left with that. So this is what I've got right here, okay? Now, real quick, let's look at my units. Kelvins match. I'm going to have a milliliter answer, so that's fine. But my 2 pressure units don't match, so you have to pay attention to that, okay? So they gave it to me in torr, so I'm going to go ahead and change my atmospheres to torr. So off to the side, I'm going to say, okay, 1 atmosphere is equivalent to 760 torr, okay? That's my conversion. So up here, where is it? So instead of putting this, I'm just going to go ahead and put 760 torr. Give myself room. All right, so now I'm ready. All my units match. I can plug things in. On the top, I've got 273 Kelvin times V1, 46.1 milliliter, and P1, 780 torr. On the bottom, I've got pressure 2, 760 torr, and temperature 2, 273. Oh, temperature 2, temperature 1. Whoops, good thing I caught that. Temperature 1, 298 Kelvin. All right, so at this point, we just cancel our units, the ones that match, torr, torr, and my answer is going to be in milliliters. Crunch that all through, pay attention to significant figures, and I end up with 43 milliliters as my volume, okay? We'll just leave this up here. I think we're going to be doing another one. All right, let's look at number 3. Number 3 says a steel container with a volume that cannot change is filled with 123 atmospheres of compressed air at 20 degrees Celsius. It sits out in the sun all day and its temperature rises to 55 degrees Celsius. What is the new pressure? All right, so let's just plug our stuff in. They said the volume, hold on, let me put this up here really quick. So they said the volume cannot change. So we get to get rid of that guy, okay? So we don't even need it in there. And volume, and volume. Okay, now let's list our stuff. We have atmospheres right here, 123.0 atmospheres. And the temperature, they said, was 20 degrees Celsius. So over here, 20.0. So now if I do this, it's going to end up being 293.2, because this is going to round, 293.2 Kelvin. And it says, what is the new pressure? That's what we're solving for. And your temperature on the other one is, it rises to 55. So if I do 55, now I'm going to get 328.2. 328 Kelvin. All right, so let's rearrange. I'm solving for P2, so let's just multiply right here. So now I have pressure 2 equals temperature 2 times pressure 1 over temperature 1. So go ahead and plug those in. Looks like I've got 328.2 Kelvin. Pressure is 123 atmospheres. All over that first temperature, which was 293.2. So cancel your units of Kelvin. You're going to end up with an atmosphere, which is good. That's what we're looking for. If I crunch it all through, I get 137.7 atmospheres. So you should be able to tell at this point that for these problems, you're really just plugging things into this formula, right? You're just labeling what you know. You might have to change a few units here and there, but you're really just plugging it in and crunching out your numbers through your formula, okay? That's a lot of what we're doing this module. All right, so let's look at the next one, number 4. Number 4 says, in an experiment similar to 6.1 that's in your book, a chemist collects carbon dioxide over water, there's that phrase you should be paying attention to, at 27 degrees Celsius. If the gas in the collection vessel has a pressure of 787 torr, what is the pressure of carbon dioxide in the vessel? All right, so remember when we hear over water, we're going to be using that table 12.1, to grab the pressure, the water vapor pressure from there. Now on your test, you're not going to have that table in front of you, so I'm pretty sure all the problems on your test, if you're going to need that, they're just going to give you that pressure, okay? So you won't have to go back and look in the book. So for this one, I don't have the table. We're going to assume that we did. All right, so they're wanting us to find the pressure of carbon dioxide. So we know we have two different things. We have carbon dioxide and water. So there's two different gases, okay? So really I have pressure of partial pressure and a partial pressure equals a pressure total. That's really what we're doing here, okay? That's Dalton's law. So let's just go ahead and fill in the blanks. The first one, the pressure of, let's say this is pressure of carbon dioxide. This is what we're looking for. And then they said the pressure too of the water is, they didn't say, but it's at 27 degrees. So if you go in your book and you look under the list, under 27 degrees Celsius, you're going to find the number 26.7 torr, okay? So you just plug that in right there. And then they gave us the total pressure. They said the pressure in the container is 787 torr, okay? So really all we need to find is this. That's what we're solving for. So we just use algebra. Okay? So if I do that, I'm canceling here, I'm subtracting here, and I end up with 760.3 is going to equal this. But I need to fix this because I can only have a certain amount of, I can only have 3. So I'm going to go whoop, whoop, use my, oops, got my torr. Okay, so then my answer is 7.60 times 10 to the second torr, and that's the pressure of the carbon dioxide. Okay, all right, let's look at number 5. Number 5 says, as part of an environmental experiment, the mixture of gases released from a smokestack is collected inside of a balloon. If the mixture is analyzed and found to contain 15 grams of SO2 gas, 12.1 grams of NO gas, and 2.5 grams of SO3 gas, what is the mole fraction for each component? Okay, so they're giving you grams of each one. I need to take those grams, you should be thinking this way now. I can't do a whole lot with grams, but I can take grams of anything and turn it to moles. Once you do that, you can find your mole fraction, okay? So that's gonna be our first step. We're gonna take each thing they listed. So they said, for the first one, they said 15.5 grams of SO2. I'm gonna set up each of these and then we'll go through them. 12.1 grams of NO. And 2.5 grams of SO3 over 1. So now we're just going to use, like we did before, we're going to just go ahead and do these conversions, okay? 1 mole of SO2, 1 mole of NO, 1 mole of SO3. So we just really need to figure out the grams of these. So we take our periodic table, we already know how to do this. We're going to figure out the grams for each one. So the first one is 64.1. I got it off that. I'm going to grab the second one, 30.0, and the last one, 80.1. Okay? So if I crunch these out, I'm going to end up with the moles. So I have 0.234 moles. Okay? Here I have 0.403 moles. And here I have 0.031 moles.